Hello students, I am Dr. Tanmay Vishwas. I welcome you all in my channel Chemistry the Mystery of Molecules. Today's topic of discussion is a comparative study between homogeneous versus heterogeneous catalyst. We will learn the basic understanding and difficulties and opportunities in these catalytic processes. Okay. You can see this is a homogeneous catalyst, this is a heterogeneous. The basic difference, homogeneous means soluble, heterogeneous means insoluble or different phase. Now let's start. Before going to details, one MCQ. Question is, which catalyst is used for hydrogenation of vegetable oil? 4 options are provided. I request you please pause the video and write your answer in the comment box, and definitely at the end of the discussion you will get the right answer. Let's start. So first, what is actually a catalyst? A catalyst is a material that affects a chemical reaction. More specifically, it accelerates or reduce the reaction rate. How? By forming an adduct, and ultimately it remains unaffected. But generally, while we say the word catalyst, we consider the rate of reaction acceleration, means catalyst increases the rate. The second one, which decreases, is considered as inhibitor. So please remember this difference. Now, this catalyst reduces the activation energy of a chemical reaction such that the reaction can occur under less drastic conditions like lesser temperature, lesser pressure for gaseous reactant. How this happened, I shall come after some time. It actually helps to bring the reactant closer such that they can efficiently react. How can I understand? For example, you have 2 hands, and by using your both hands you are holding 2 other person, and in this way you brought these 2 person closer together such that they can communicate with each other efficiently. So you may consider that the person you is the catalyst and the 2 person you have hold their hand are the 2 reactant. Because of you they come closer and they communicate with each other efficiently, or you can say they have developed a chemistry between them efficiently. Now, for example, acid or base can act as a catalyst in ester hydrolysis. Enzyme catalysis is also a kind of catalysis, means like protein into amino acid, petroleum cracking in oil refinery, or water oxidation to corresponding fuel like hydrogen and oxygen. And by the way, some justification I want to give from my side, that why do I bring energy and environment related issue always, or during my teaching why don't I provide simple traditional examples? Now the main reason to do this, because student, you are the future of every country, your individual country. Without your active participation, global problem could not be resolved. So that's why it is highly desirable that if you prepare yourself from the early ages by right pathway, then the probability of getting success of your life will increase, and consequently your knowledge and proper training will help you to secure better earning. And why earning came with this catalysis topic, at the end we'll get the answer. So from my understanding, I always believe that learning with earning is most sustainable. So please train yourself such a way that not only you learn, you make yourself eligible to earn. Now let's come to our main topic, role of catalyst. How catalysts do such kind of unique jobs? By lowering the activation energy of a chemical transformation. You can see this thing clearly. A reactant is getting converted into product, and the activation energy in presence of catalyst, you can see this green, is far lesser compared to the activation energy without catalyst, means this much amount. And that's why the rate enhances, means rate of a reaction is dependent on the energy of activation. More the energy of activation, less the reaction rate. Or if activation energy is more, you need to provide more energy to bring the reaction to happen. So that's why since the activation energy reduced, reaction became easier to happen, means the catalyst makes the life easier to achieve the product under relatively less drastic condition. This is the simplified picture, student. In reality, catalyst forms an intermediate with the reactant. So actually, if you look at the graph, first it comes here, then this is the intermediate, then this is the product. Okay, so this is the reactant, this is the product, and this is the substrate catalyst intermediate. But after the chemical reaction, the catalyst eliminate and remain unchanged. Consequently, very small amount of such material, means catalyst, is enough to carry out a particular reaction. So that's why we say the process is catalytic, means small amount of catalyst is needed. Since it is regenerated, it participates again, and this process continues until all the reactants are converted into corresponding products. Now, how does a catalyst work? As an example, let's learn about the ester hydrolysis by acid. What happens in this case? First, in this case I am saying acid, means it is actually H plus catalysis. And by the way, when we use any solvent, H plus doesn't remain as H plus. If it has any oxygen atom or nitrogen atom, it gets protonated. For example, if you do the reaction in water medium, what will happen? This water will produce and protonate and produce H3O plus. This hydronium ion is then the source of acid. So what happens? First, this ester oxygen, this carbonyl oxygen of ester gets protonated. Why this is? Because of the canonical form, means you can consider this lone pair will come here, so it will go. So in this way it will produce RCOO minus and OR prime, and in this case this is the plus. So from this thing you can understand the negative charge density is expected to be more on this carbonyl oxygen, and that's the reason why these esters get protonated on this carbonyl oxygen. Now let's compare with this substrate, means neutral ester, with the protonated ester. Proton means electron deficient species, the cationic species. Cationic species means deficiency of electron. So after protonation, that this carbonyl carbon, means ester carbonyl carbon, became more electron deficient. Now water can attack at this position, and this is a nucleophilic addition step. Later on, this lone pair pushes here and this OR molecule leaves. In this way it produces this this is actually a neutralization. In next step, see here it is shown that this water pushes this which leave, and it ultimately produces the protonated acid. After removal of this H plus, it produces RCOOH. So this is the carboxylic acid, and along with that here R prime OH, means the alcohol is also produced. So this is the overall reaction for these purposes. So from this thing we have understood that how this reaction happens. Now, based on this understanding, we can say that two types of catalysis are possible based on the phase of the reaction and the miscibility. Now, so based on that we can differentiate in two types of catalysis. One is homogeneous catalysis, which happens in the same phase, and heterogeneous catalysis with different phase. Now learn first homogeneous catalysis. Homogeneous catalysis is a process inside a chemical solution with a soluble catalyst, means the catalyst, reactant, everything is soluble in the same phase. That's why this is homogeneous catalyst. Now, the heterogeneous is different phase. I shall come later on. Example, as I told, ester hydrolysis by acid and base, just I have shown that is a homogeneous, because in this case these H3O plus, these ester, all are in same phase, means they are soluble in a medium. Now, enzyme catalysis is also a homogeneous catalyst, remember. Now, what is the advantage of this homogeneous catalysis? So, these homogeneous catalysts are generally more reactive and more selective. Just think, for a chemical transformation, what do you need? You need a more reactive and more selective catalyst. So, this is provided by the homogeneous catalysis. Not only that, how they are more reactive and more selective. For example, if you are carrying out an exothermic process, means the reaction will produce heat. So that heat will be given to the solution reaction mixture, and we know increasing temperature reaction happens efficiently. It's a general trend. So reaction will further speed up, and in this way this reaction will continue until all the reactant are consumed. Generally, what you observe, the rate of reaction is dependent on the active mass of the reactant, like law of mass action. But since the heat is added into the reaction mixture, what will happen? Reaction will proceed smoothly and very quickly it will end up to the end point or conclusion or completion of the reaction, and that is the beauty of homogeneous catalysis. Homogeneous catalysts are easier to characterize precisely. Why? For example, using NMR spectroscopy or FTIR, because homogeneous catalyst, in case of homogeneous catalysis, the catalyst reactant both are soluble in reaction in a particular medium, so you can check the FTIR spectroscopy or NMR spectroscopy of the reaction mixture and you can check progress. For example, you are doing a reaction where a CH is converted into C bond. This is this thing you are overall doing. So this CH has a particular position in NMR spectroscopy, but when it converted into CC, then it's gone, and number of proton is actually the area under the curve integration NMR spectroscopy. So slowly you will see the area under this proton is getting smaller and smaller. So in this way you can study the kinetics. Not only that, for example, you are doing a CC into something where, for example, a carbocation formation, there is a H, there is a C plus. So for that case, one alkene is converted into a saturated species. So for that case, what you can do, you can check FTIR also. So that's the beauty of homogeneous catalysis, and that's why they are very much helpful to determining the mechanism of a chemical reaction. Okay. Not only that, for homogeneous catalyst, sometimes people are able to separate the crystal of the intermediate. I know you will not believe, it's true. Means a catalyst is actually a coordination complex, is reactant and catalyst that got make sometime crystal, and from that we can conclude how the reaction happening. So that's the best proof based on my understanding. So that's the unique character of homogeneous catalysis. Now, is there any disadvantage? Always. Otherwise, why heterogeneous will exist? Now, homogeneous catalyst, what are the advantage? The biggest advantage is separation of the homogeneous catalyst from the reaction mixture after the reaction is completed. Why? Because they are miscible, so it is difficult to separate, and that's why sometimes toxicity could be observed because the catalyst is mixed with the product. Possible. For example, you are preparing a polymer using a homogeneous catalyst. The catalyst is inside the polymer because it is very difficult to separate the catalyst from the polymer. Okay, and in this case, some valuable metal center could be lost during such chemical transformation. What do I mean by the statement? For example, you are doing a reaction using palladium, iridium, etc. metals, and remember, student, they are very costly. Sometimes more costly than even gold. So they are noble metal, they are very much catalytically active metal. So we can't afford to lose such kind of catalyst after every batch of chemical reaction. And for that purpose, if you want to separate, we need to do tedious workup and purification step, and these will create additional step, and additional step creates cost. So chemical transformation cost increase, although reactivity selectivity is more, but cost is also more in case of homogeneous catalysis. And not only that, thermal stability is also sometimes significantly less. So what do we want actually? We need a catalyst to be separated easily, relatively less soluble in the organic means reaction medium, significantly reactivity should be there and selectivity also, and which will have lesser environmental impact. And if these criteria are fulfilled by heterogeneous catalysts, and in this case, what is the difference? They are actually in different phase compared to reactant and product. Like in homogeneous catalyst, they are in same phase. So this is the biggest difference, student. First of all, phase difference. Second, reactivity generally for heterogeneous catalyst is less because they are not soluble in the reaction medium, but they can react with different phases. Means, for example, you want to react with one liquid and one gas, this heterogeneous catalyst can do, or you want to react with different substrate or immiscible mixture, means oil and water. They both are liquid but they are not miscible. That's why you can use in that case heterogeneous catalyst. So these are the main difference, and based on this difference we can say that these heterogeneous catalysts are far better. And actually in this case, the unique thing is that the reaction happens on the surface of the catalyst, which we sometimes consider as the active site of the catalyst. and that's why the surface of the catalyst is very important. Surface morphology, structure, active sites are important, and in this case the entire catalyst, for example, a homogeneous catalyst is made of 100 molecules and doing the reaction, then 100 molecules are expected to participate in the reaction. But if a heterogeneous catalyst you are making, maybe it consisted of 100 molecules or particles, but only 40% molecules are on the surface, so that 40% are expected to participate in the reaction. So that is the difference. An example for a very good example, that is ammonia synthesis from hydrogen plus nitrogen using iron oxide as heterogeneous catalyst, or zeolite. These are aluminosilicates material used in petroleum cracking. They are extensively used, student, and these ammonia preparation reaction is so much important that you can consider presently 50% of global population exists because of this one chemical reaction, because this ammonia is later on converted into urea, which is the most widely used synthetic nitrogen fertilizer. That's the importance of the catalysis, you can understand. Now, so based on this much understanding, I want you to answer this question. It's a very important question nowadays. Nanomaterials or nanoparticles, are they homogeneous or heterogeneous catalyst? Please pause the lecture and write your answer in the comment box. I want to know your opinion. If possible, write a brief justification. Now, let's come to the example of this heterogeneous catalysis, that is hydrogenation of alkene using hydrogenation of alkene using this heterogeneous catalyst. In this case, this catalyst based, for example, this is the palladium catalyst bed. So this is heterogeneous because it is not miscible with the substrate, and in this way this reaction happens. This alkene you can see first attached. For example, your left hand hold this alkene, right hand hold this hydrogen, means both this left hand this is the right hand and this is the left hand holding this two reactant. Now they react, means from here to here one hydrogen is transferred, and again second hydrogen is transferred, and this ethane is the product. By the way, details description with mechanism I have given in a dedicated lecture, you may visit. So let's come to the most important point, as I told some time before, why catalyst is so much important and it can help you in earning in future. Because catalysts are directly related to the economy of a country, and that is the importance of this chemistry. More specifically, if I say that if a country have expertise in catalysis, it is one of the leader in chemical industry. And please remember, global chemical industry is in trillion US dollar industry. It's a very big industry. And here estimate says that 90% of all commercially produced chemical products involves catalyst at some stage of their manufacturing. So just try to imagine how much important these catalysts are in chemical industry. And industry means income opportunity, and income opportunity is also associated with development. Now, not only that, some future problems which are some recent future based problems are expected to be solved using catalysis, like carbon dioxide fixation to stop the global warming, or water oxidation to fuel generation like hydrogen and oxygen, which we consider as a future fuel. And in order to replace the fossil fuel based infrastructure, we need this chemical reaction, and for that purpose also we need catalyst. What do I mean by the statement? For example, if you take to stainless steel rod and you do the catalysis, means take stainless steel rod deep inside the water, I guess you have learned this thing in your thing, that okay fine, this is a setup, DC you provided, now this is a solution in presence, this is a alkaline, neutral or salt containing solution. If you provide electricity, this what you get, this negative charge electrode will produce hydrogen gas, and the positive charge electrode is expected to produce oxygen gas. We know this is possible, but instead of a stainless steel electrode, or if you consider it as a platinum electrode, there is a difference. Both reaction will happen, but to get a particular amount of hydrogen and oxygen, you need to give more energy in case of stainless steel electrode compared to platinum. How? That is the over potential, and that is the role of catalyst. Not only that, this platinum is very costly, so that's why it is not possible to produce hydrogen and oxygen worldwide using platinum based electrolysis. That's why scientists are trying to prepare other catalyst also. So that is the biggest research challenge nowadays, and catalyst plays the role. And what this catalyst does, catalyst reduces this much amount of energy, student, this much delta E. Actually, in presence of catalyst, we are able to save this delta E amount of energy, and the global economy is focusing on this much amount of gap. From this, they say that, sir, how much important this delta E? Just consider the energy production for the entire planet. Not only that, for chemical transformation, if you consider, you need to provide energy for any chemical transformation. So for that purpose, if you are able to reduce the input energy to prepare any particular product, your profit margin will increase. Not only profit margin will increase, the pollution level will also decrease, because from where we produce the energy, we produce energy from fossil fuel, student. Till now, majority of our energy, more specifically say if you say electricity, coming from fossil fuel. So that's why we need to reduce the energy requirement of a chemical transformation, and that is possible by you choosing proper catalyst. Not only that, we can save our planet using catalyst also. So this is the importance. Now let's come to our MCQ. Which catalyst is used in the hydrogenation of vegetable oil? See, here 4 options are given: titanium, lithium, nickel and uranium. Please remember, this nickel, palladium, platinum, those are very efficient. This nickel, palladium and platinum, same group, they are very much efficient in absorbing hydrogen. Just sometime before, remember the slides I have shown hydrogenation reaction. For hydrogenation reaction, first hydrogen need to get absorbed on the catalyst, then only it can do hydrogenation, and these nickel, palladium, platinum can do this job efficiently. Now if you look at these 3 catalysts, see, nickel is relatively cheaper and this palladium is relatively more costly, platinum is further more costly. Not only that, they have toxicity also. So from this point of view, you can understand it is highly desirable if we can use nickel based catalysts which are cheap, widely available, so you can use extensively. Okay, and this is the example. You can see this nickel catalyzed hydrogenation of fat, means the option C3 is the answer. So you can see in this reactant many double bonds are there. There are 2 double bond, there are 2 double bond, here 1 double bond, and after hydrogenation of this, actually you may consider this is a oil, liquid oil. So oil, this is in liquid. So after hydrogenation, what happens? See, it is true that all double bond doesn't get hydrogenated, but majority of got hydrogenated, and in this way it is called as converted as fat, and this is solid. What is the difference? Actually, from common terminology there are different, oil and fat, but for chemical terminology if you think, both are same, but their phases is different. One is liquid, one is solid, because of this extent of hydrogenation. And advantage of this process is that vegetable oil could be converted into product like animal fat. I would say animal fat like product, like margarine. So in this way you are producing a animal fat like material using a synthetic method. So what you are doing, actually you are reducing the cost of the final product, and most importantly you are saving some animals too. So that is the uniqueness of this catalysis process. Now, so this is the overall discussion. Thanks for watching. If you have enjoyed my teaching, please help this channel, and I request you, if possible, please visit my another channel, that is Climate and Chemistry, where I upload global warming and climate change related videos. So thank you again. See you in my next video. Bye bye.